So today I'm going to be looking at linear modeling, which we've actually done before, just like we'd looked at y equals mx plus c before, and they are the exact same thing. But now instead of applying it to y's and x's, which don't mean much to us, we're going to be applying it to real world situations and graphing them to kind of infer information from them. So the first thing I'll say before we start anything is probably the one important thing you need to remember is that gradient is spelled with an N, represents y's per x. Now that sounds a bit silly on its own, and that A is very illegible, but too late now. But whatever's on the vertical column, it's some number of those per whatever's on the horizontal axis. And that's going to get you a rate or ratio of some kind, and they're often going to ask you a question when really what they're asking is the gradient, but it's going to be disguised as a y per x or dollars per person, something like that, maybe kilometers per time. And really what it's asking is the gradient. So if you can remember this, gradient represents y's per x, then you're going to do all right. The other thing is the y-intercept represents the starting amount. So it's kind of two key things to remember. So let's say the cost of producing chocolate milk is $1 per bottle of milk, but you got to buy $400 worth of equipment first. Well, that initial starting amount is $400, and so that's where you're going to hit the Y, the vertical axis, and then go up from there. And you notice there I said dollar per bottle of milk. You can figure that out. This is the gradient. $1 per one bottle means a gradient of 1 already coming into it. So let's have a go. Let's do this bottle of milk one. E.g. a factory produces bottles of oak for, let's say, $2. If the machinery costs $500, plot the cost of producing 0 to, let's say, 100 bottles. Now, a couple of ways we can do this. Whenever we're graphing, we can think table of values. We don't really have an equation here, but it's not too hard to work it out in our heads anyway. Or we can be thinking y-intercept and gradient. So let's do both of those here. So y-intercept is the starting amount, so y-intercept we call C, and gradient is cost per bottle, so M. Now we only need this part of the coordinate for most of these, if not all, because in the real world a lot of values are positive, and particularly in this course we're looking mainly at positive values. Now we know this is going to be starting at 500, so why don't we go up in lots of 100, 100, 200, 300, 400, 500, 600, 700. Gonna be a bit cramped, sorry. It's important we don't skip any down the bottom because we need it to all be to scale. So that is cost in dollars. That is not a great S. Cost Alright, down the bottom is bottles of milk. And we want from 0 to 100. Why don't we go up in tens? So 10, 20, 30, 40, 50, 60, 70, 80. 90, 100. Now we know, before we even produce a single bottle, we're on 0, which is on the line, not in front of the line. Make sure you're doing on the line. And then from there, it's going to cost $2 per bottle. So when we get to $600, how many more bottles would we have made? That could be one way of thinking about it. Or you might pick a round point. Let's say 50 bottles. How much does it cost to make 50 bottles? Well, $2 a bottle. It's a $100 increase. So it's going to go up to the 600 at 50. And then it's going to go up another 100 by the end of the graph at 100. And draw your line through there. Obviously, using a ruler to line it up nicely. But it's going to look something like that. And that is the cost of producing anywhere between 0 and 100 bottles of milk shown on a graph. You can see it was just the formula y equals mx plus c, but we know this is the y-intercept, the starting amount, so we used 500, and m was the gradient, how much per, and it was $2 per. So y equals 2x plus 500. You can substitute for letters as well. You could say C for cost and maybe B for bottles, something like that, instead of Y and X. Alright, most of these questions though, they're going to be interpreting graphs that are already there. So let's, I'll pause the video and I'll grab a graph to put in here. Alright, we're back. So we've got a graph here, and there'll be a lot of different questions that you might get asked about this graph. So, for instance, well, I should actually include as well more information. So let's put that in as well. Now that I've got it up, it's not too hard. So it says Grace sells insurance. She earns a base salary and commission on each new insurance policy. That's a tongue twister. Each new insurance policy she sells. The graph shows Grace's weekly income, I, plotted against the number of new policies, N. So income per policies. You're thinking per, that is gradient. And then she sells in that week, the relationship between I and N is linear. That just means when you graph it, you get a straight line, which if you look at corona cases, is not the case. It is very exponential, which is a worry. Now, not to put that existential dread on you, let's answer a question. What is Grace's base salary? Because it says here she earns a base salary and then commission. So starting amount, we're thinking y-intercept. So base salary equals $400. Alright, next question. Says, what is Grace's salary in a week in which she sells 8 new policies? Well, that's pretty easy. We come along to 8, go up until we hit it. That's 800. So 8 policies salary equals 800. Salary is really not the correct word here, but it's what the textbook uses. How many policies does Grace need to sell to earn 700 for the week? Well, 700 is going to be here. Reading across till we hit the line, ruling down. You can see there, 7 policies is going to be $700. Alright, Find the equation of the straight line in terms of I and N. So remember, I is on the vertical, so we're putting I instead of Y, and N is on the horizontal, so N instead of X. So I equals M N plus C. Y equals MX plus C. I've changed it to I equals MN plus C. So income equals, well, we know where the graph starts. That's $400. The only other thing we need to find is the gradient of this line. So we can do that anywhere, but I reckon here's pretty easy. It goes across 4 policy, goes up 200, which means M equals rise over run 50. We've got our equation. $50 per new policy, and that means the gradient is 50. The last question says, how much does Grace earn for each new policy? Well, you're thinking gradient here, $50. Alright, so I'll send you guys out a class kit to complete now. Please do it during the allotted time so I can be checking during the lesson, and then there'll be work to go on with after that from the textbook. Good luck.